Section 1.5, we're talking about absolute value. So this is our last topic. So I'm just going to say this before we get started. This is the last thing in this chapter. So if you can print off, I sent a message out yesterday, print off your hand-in, check it out during the weekend, and Monday's class we'll be working on it and making sure it gets handed in. So there's no new video for Monday. A video is going to be on Tuesday. I'm going to start chapter 2, and Wednesday I will have our exam. Okay, so Monday, the hand-in is due at 3:30. Make sure it gets in. I'll correct it, make sure it gets back so that you have it to study for the test that is on Wednesday. Okay, so absolute value is, remember, absolute value talks about distance. And so we never say I'm going negative 5 blocks home. You're going 5 blocks home, right? You're not going to negative distance. So absolute value, when you're in absolute value, everything's coming out as a positive. Okay, so the absolute value of negative 11 is just 11. Okay, when we're inside absolute value, you still do math the same way, and then whatever answer you get, you take it out of absolute value as a positive value. So 8 minus 10 is a negative 2, and it's still an absolute value, and when it comes out, then it comes out as a 2. Okay, so we look at absolute value and it's split up like this. So absolute value of b, so b comma if b is greater than or equal to 0, and then negative b if b is less than or equal to 0. So we still have to do a plus and minus part because we don't know if inside the bracket it was positive and negative to start with. Okay, so for absolute value we always look at a positive area and we look at a negative area. So the sign analysis of x minus 3 is shown on the number line below. We are going to use expression analysis of x minus 6 below the number line. So all we are doing is we have our factor was x minus 6, and we did some of these yesterday, right? And so if I put anything on this side of 6 on this number line, like 10 into that, 10 minus 6 is 4. That's a positive, so positives go this way. And then negatives are going this way. Okay? And so when we total this one up, there's only one factor, so positive here and negative here. Whoa, sorry. Where did I go? Okay, here we go. So then it says look at the above line, and we see that x minus 6 is a non-zero if x is greater than or equal to 6, while x minus 6 is negative if x is less than 6. So all they're saying is the positive side is to the right of 6 and the negative side is to the left of 6. And so we can write this in that form we just talked about. So our factor was x minus 6. And if x is greater than or equal to 6, that's where it's positive. Okay, so we don't necessarily need this positive out in front, but I like to put it there just as a reminder because it reminds me I have to do a positive version and then I have to look at the negative version. Okay, so is the plus necessary out front of there? No, but I like to keep it there just so that I keep track of what I'm doing. Okay, so then I have to do a negative version as well, right? So where was 6 negative? It was less than 6. Okay, so all we did was split it up to explain where x minus 6 is positive and where x minus 6 is negative. Okay, so this example says we're going to do sign analysis for this, the absolute value of 16 minus x squared without absolute value signs. So we must determine the signs of 16 minus x squared if 16 minus x squared is non-negative, and with the negative 16 minus x squared if 16 minus x squared is negative. Okay, so that sounds like blah 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 blah, but all we're doing is we're doing sign analysis and we're looking for where it's positive and then where it's negative. That's all we're doing. Okay, so we're going to put our factors up. So let's factor this first. Okay, so if we had 16 minus x squared, that's the difference of squares, right? So how could we write that as a factor? Okay, so we have to be careful in this one because it's not x minus 4 and x plus 4. It's 4 minus x and 4 plus x because the 16 is first here. And if you're thinking, what the heck is the difference? There is a difference. And we'll get into that when we get to the sign analysis. So our factors, we just said, are 4 plus x and 4 minus x. Okay, so our zeros are when 4 minus our 4 is for the 4 minus x one. That's what makes that 0. And a minus 4 or a negative 4 makes the 4 plus x1 0. Okay, so now if we tested these out, if I put something that's greater than minus 4, so say I put 0 in, 4 plus 0 is 4. So it's positive going this way. And negative going the other way, because if I put negative 10 in, 4 subtract 10 is minus 6. Okay, so now what about this other one? So if I put something greater than 4 in, so say I put 10 in, 4 minus 10 is a negative 6. Okay, and we say, oh, because that's different than what we thought before. That's why it's important it's factored correctly, right? And if we put anything like 0 is anything less than 4, so say 0, 4 minus 0 is 0, so it's positives going this way. So we have to be careful that we pay attention when we do our sign analysis with our factors. Okay, so now when I total this one, a negative and a positive make a negative. Two positives make a positive, and a positive and a negative make a negative. Okay, and then we can write this in this form. So it's saying the positive version of 16 minus x squared if x is, and so where is it positive? Right, it's in between. It has to be greater than minus 4, but less than 4. So we'll put our x in the middle, and we'll say it has to be greater than or equal to minus 4, and less than or equal to 4. Okay, and I always just include in the positive and not in the negative. It's not really, there's no right or wrong, it's just you can't use greater than or equal to in both, because that would mean you're including the values in both positive and negative. So you just choose. I always put the greater than or equal to signs in the positive so I remember, and then just the less thans in the negative one, and don't include them in both. Okay, and so in this one, when we're talking about the negative version, where is it negative? It's negative less than minus 4 or greater than 4. Okay, so from, oh, and maybe we should write this, I'm torn between. So I always like to write it in interval notation. So, oops, hold on. Negative infinity to negative 4, and 4 to infinity. Okay, and if this first one was in interval form, it would look like from negative 4 to 4. Okay. When we look down the page, we have operation properties for absolute value. Okay, so we just have to notice product property. If you have two things multiplying inside absolute value, then you can split them up as in the absolute value of B times the absolute value of C. Same thing works for quotient property. if you have two things dividing inside absolute value signs, then you can split the signs up and divide. The power property, where b to the power of n, you can write it as the absolute value of b and then to the power of n. And the square root property, meaning the square root of b squared is the same thing as the absolute value of b, because when it comes out of there, it's going to be positive. If you square something and then root it, it has to be a positive answer. Okay, so this one says show that the absolute value of x squared minus 9 over the absolute value of 3 minus x is equal to x plus 3. So they have the answer there, and they're saying provided that x cannot equal 3, because that would make the bottom undefined. Okay, so first we're probably going to factor the top. So this is the difference of squares, so it's the same thing as having x and 3 and 3. So I can write it as x minus 3 and x plus 3. And it's all over 3 minus x. Okay, so usually we can cross off things that are the same. What happens when we cross off things that are opposites? Yeah, you cross off and you get a negative 1. So this guy and this guy can cross off because they're opposites. The x was positive in the top, but he's negative down here. The 3 was negative in the top, but he's positive in the denominator. So those are opposites. So they cross off and they become a negative 1. We're still talking in absolute value though. Whoops, and I forgot a bracket there. And we still have the absolute value of x plus 3 there. Okay, so what is the absolute value of negative 1? It's 1. And 1 times the absolute value of x plus 3 is just going to be, yeah, the absolute value of x plus 3 or x plus 3. So it says prove that x plus 3, the absolute value of x plus 3 is the answer. We just did that. Okay. We'll move farther down. And these ones are solving equations with absolute value. Okay, so it works the same way as when we split them up in those brackets before. We look at a positive version and we look at a negative version. So you're always going to be solving it in two ways in this equation. So you can write them out of the absolute value brackets, and you're doing for a positive 86, and you're taking this out of the absolute value and you're doing it for a negative version. So then we just have to solve for x in both cases. So I will add 11, and I have negative 5x is equal to 97 divided by negative 5, and I have x is equal to, what do I have? 97 over negative 5. I don't think it simplifies. What's up? Yeah, a plus version, a negative version. I would leave it at a ridiculous fraction instead of decimals. Then if we do this one, you're adding the 11 over, and you have negative 5x is equal to negative 75. Divide by negative 5, and you're left with x is equal to 15. Yep. Second example is done the same way. So if we take 5x minus 3 out of absolute value, we're going to do a positive version, and we're going to do a negative version of the equation, and then we just solve for x. So we'll add 3 over, and you have 5x is equal to 10, and when we divide by 5, we end up with x is equal to 2. And when we add 3 on the other equation, we end up with 5x is equal to minus 4. Divide by minus, or sorry, that's not a minus 5, it's a 5. Divide by 5, and we end up with negative 4 over 5. Okay, for this next one is a trinomial, so you could try doing like what multiplies to this adds to that. There's nothing that multiplies to minus 4 that adds to 2, so then what does that mean? Quadratic formula. But first we'll just take this out of absolute value, and we'll have to do a negative version, and we would do a positive version with the quadratic formula. So to get everything on one side, I'll just add this one over here, and I will, oops, I did 2 of the same, so we'll subtract the 1 over here. So our equation is x squared plus 2x minus 3 equals 0, and x squared plus 2x minus 5 is equal to 0. Okay, and so just to look at this even, now that we have our factors here, sorry, we shouldn't have tried to do quadratic formula until this was completed, right? So now, if we look at it, does anything multiply to minus 3 and add to 2? Yeah, in this situation, x plus 3 and x minus 1 work. So our x's are minus 3 and 1. Okay, but in this situation, does anything make a negative 5 to a 2? No, so then we'd have to do the quadratic formula for this one. Okay, so remember the quadratic formula is minus b plus or minus b squared minus 4ac all over 2a. Okay, so our a in this situation is what's in front of x squared, so our a is going to be 1. Our b is what's in front of x, so it's 2. And our c is minus 5. Okay, so to maybe save time on the video, instead of plunking it all in, you're putting it into the equation, and we will end up with a negative 1 plus or minus a root 6. Okay, so our answers for this one are minus 3, 1, and a negative 1 plus root 6, and a negative 1 subtract a root 6. So you have 4 answers. Okay, and our last example is expression analysis. So we are given 2 absolute value equations, and we're going to do sign analysis, but it's a little bit different with absolute value. Okay, so we have this as one of our factors, and a 2x plus 5 is one of our factors. Oh, where did I go? So for my sign analysis, I'll put my number line down below. My factors are 2 minus x and 2x plus 5. Okay, and so then we need to know the zeros that go with this. So the 0 for this one is 2. Okay, and how do we find the 0 for 2x plus 5? Yeah, it's negative 5 over 2, because what you do is you go 2x plus 5 equals 0, and you solve to see what x would have to be to make it 0. And it would be negative 5 over 2. Okay, so on our number line, negative 5 over 2 is the same thing as negative 2.5. So he will be somewhere over here. Okay, so then when I check out my sign analysis, if I put anything greater than 2 in here, like 10, 2 minus 10 is negative 8. So negatives going this way, positives going this way. And just a question, is it always negatives and positives, or positive and negatives? Like, is there ever a situation where you get straight negatives or straight positives? Yep, you could. if this had a squared here, anything squared is positive, right? Even when you come out with a negative, you square it, you get positive. So if you ever have a squared on the outside, or a squared value for your x, then you're going to have positive straight across in your sign analysis. Okay? Okay, and then in this situation, say we put 0 in because it's greater than negative 5 over 2, we would end up with positives and negatives going this way. So I total them up usually, but I'm going to not do that at this moment. We're going to stop because in an expression analysis, it's done a little bit differently. Okay, so what we do is we say in this section right here, our equation, which was 2x plus 5, is negative. So I go negative 2x plus 5. And in this section here, so we need to think of these as little sections. Okay, this section here, the 2 minus x was positive. So what we're doing is kind of making an addition of those factors straight down. Okay, so then in this section, right here and here, both of the equations are positive. So I had a positive 2x plus 5, and I have a positive 2 minus x. Okay, and then this last section here, my top equation is positive because of the positive signs here, and my bottom equation is negative. Okay, and then what we're going to do is we're going to add and total all the way down. So we are adding these common things together just straight down for addition, but we need to, these aren't organized properly. We have a 2 minus x, and in this one we have a 2x plus 5. So we have to make sure we're putting the right pieces with the right pieces. So if you want to switch your bottom equation so it's a minus x plus 2, you can do that, or if you're not going to get confused, then just leave it. Oh, come on. It doesn't want me to erase it. Oh, here we go. So I'm going to switch mine to a negative x plus 2. Okay, just so that I can add straight up and down. So a minus 2x added to another minus x is a minus 3x. And then a 5 added to a 2 is 7. Oh, sorry, yeah, negative 5, you're right, negative 5. Add 2 should be negative 3, right? Come in. There we go. Because there's this negative here, and the negative goes to there. Okay? So we have a negative 2x added to a negative x is a negative 3x, and then a negative 5 added to a 2 is a negative 3. Okay, and then in this next section, these are both positives and we're adding, going down. So we can reorganize it again. Okay, come on, erase. It's not letting me erase it. Oh boy. Okay, we'll just leave it as is. So we're going to go 2x minus x is just an x. And then we're going to go 5 plus 2 is 7. And then in our last section, we have a 2x subtract a negative x. So subtract a negative and a negative make a positive. So we have a 3x. And then we have a 5 subtract a 2, which is 3. Okay? Sorry if that's messy. My eraser is not erasing. Okay, so then we cruise down here and we put it, where are we? we put it in this notation. So all it means is our first section was minus 3x to minus 3, right? We were in minus 3x to minus 3 in that first section, and if you look at that first section, this first section went from negative infinity to negative 5 over 2. Okay, so that's how we label it. It is from negative infinity to negative 5 over 2. Okay, and this little bracket here is just saying they don't really know where you include the number and where you don't, like with square brackets. So for any purposes for us, I'm okay with just leaving it as round brackets. Okay, because it's kind of, they're saying it's arbitrary to if that you include it in this section, the square brackets, or you're included in the other one or the other one. Okay, so in this case, we can just leave them as all round brackets if we want, or all, well, we can't include everything, right? So round brackets is probably the safest way to do it. Okay, our second section, oh my goodness, was, where are we? Was x plus 7, and it went from negative 5 over 2 to 2. So we had x plus 7, and it was from negative 5 over 2 to 2. And our last section was 3x plus 3, and it went from 2 to infinity. Okay, so that is expression analysis for absolute value. And then just our last piece here, this is just saying that if you have a graph, remember absolute value wasn't supposed to include negatives in the picture, so anywhere where the picture is going down into the negative section, you reflect it up, and that would be the absolute value of that equation. Okay, so your picture would not be including anything in the negative area. So our assignment is kind of crazy. I messed it up a little bit. So if you're looking at the video, please take note of the change in the assignment. We're going to do 1 to 23 odd. So odd numbers are 1, 3, 5, 7, so on, so on, so on. And then we're going to do 29, 33, 34, and 43. Okay, so note the change in the assignment.